Awesome. Jim, we're recording. Let's go.
Excellent. Welcome everybody to Office Hours number 20. This week we are going to be foregoing our regular discussion topics in order to host a special fireside chat episode of Office Hours with our friends at streamingfast.io. This session is a chance for indexers and I guess anybody in the community who's interested to get to know the team, to ask questions, to understand what Streaming Fast's arrival means for the graph, software performance, and the ecosystem as a whole. So just as a little bit of background for everybody, if maybe you've been living in a cave and aren't aware of what's been going on around the graph in the last, the last 2 or 3 weeks, Streaming Fast have joined the graph community as an additional core developer team on the protocol alongside Edge and Node, as part of a $60 million grant that brings Streaming Fast talent, technology, and leadership into the ecosystem. Streaming Fast is a protocol infrastructure company that excels in building scalable cross-chain architecture for streaming blockchain data, which is what we're all about at the end of the day, right? We're here about to deliver data. Today, we're lucky enough to have some of the team joining us for a chat. So I'll just go through a quick bio of our 4 main guests here. But I'm aware that we have more of the team available on the chat. So any of you who would like to, take part in this discussion, you're more than welcome to chime in at any point. So to start off, we have Marc-Antoine Ross, the CEO at Streaming Fast. Mark is a sort of get stuff done kind of guy. He is a tech entrepreneur with 3 exits and is constantly striving to bring out the best in people. Mark, welcome to today's Office Hours.
Thank you, Jim. Hi, everyone.
We also have with us Alex Bourget. I hope I'm not massacring that, Alex. CTO today at Streaming Fast. Alex is an inspirational and prolific innovator with insane technical depth. Alex is unstoppable when he takes on the most complex challenges. Having productionized multiple high-performance data platforms, he's demonstrated his ability to help a team ship the best-of-breed software. So did I massacre your name there, Alex? If I did, I'm so sorry. Can't hear you, Alex, for some reason. No, we've lost you.
I can say that you massacred his name.
Okay, moving on to our third guest. We have Matt Vachon. Matt, have I massacred your name as well? I'm not doing too well here, am I?
It was better, I would say.
Okay, so Matt is a blockchain architect at Streaming Fast, and Matt has held multiple R&D roles up to CTO before joining Streaming Fast. His courage to explore, define, and execute missions across multiple ecosystems is unmatched, always keeping in mind the end user's goals and preferences. Welcome, Matt.
Welcome, everybody. I'm happy to join the community and help where I can.
Excellent. And last but not least, we have Josh Kaufman. Josh leads the community and governance side at Streaming Fast. Josh has helped to both rally and educate different blockchain communities to the many advancements that the Streaming Fast team have built. His focus lies in helping others to understand the blockchain world and how governance gets built in a globally distributed open source community. Josh, welcome.
Thanks a lot, Jim.
Great. So, Alex, I just want to check in before we start to make sure your mic is okay. Let's get that sorted before we move on. Could maybe one of the guys ping Alex and help him out?
I think he's just left, right? Can we join?
Yeah, he just joined if someone wants to pull him back in.
Yep. I need somebody who's got admin to be taking care of these requests to join the stage, please.
I invited everyone, so it should be fine.
Okay, let's get started, guys. So I've got a few different themes I think we'll touch on today, but if anyone has any sort of questions as we go, wants to steer the conversation in a different direction, please feel free to do so, especially once we get into the technical stuff. So let's start, I think, by let's maybe get a bit, let's learn something a little bit about the team members and their crypto origin stories. I always like to hear where people started in crypto. So we'll just go through from the top there. Mark, where did you get your start in the crypto space? How did you end up where you are today with crypto?
Yeah, it's funny because, our last startup was called Passwordbox. I was working with Alex from 2014 to 2017. And you'll see that I'm a very focused person in life. And I was focused on our data engineering mission at Intel. And Alex was sitting right next to me every single day talking about blockchain. And I was, slowly being infused about all these concepts, but not really paying attention. But when I left Intel in 2017 and I started digging a little bit more, I realized and understood what Alex had been sharing for over 3 years next to me. And I called him back and said, I'm exploring some blockchain opportunities in the fintech space. Are you interested in exploring with me? And this is how the story started again.
That's interesting. So at Intel, were you working on software stuff? Were you working on the hardware side of things with Intel?
We were working on the software side of things. We were building a telemetry system for Intel, distributing the software on over 200 million devices a year, and basically tracking all the end user's behavior in specific software that needed this real-time analysis for malware or stuff like that. And this is where I guess Alex and I were able to demonstrate our ability to push the limits of data engineering.
Crazy loud. I think we are trying to help him, but not sure what's happening.
A little bit quiet.
So very sorry. I'm on Linux. There's a switch. It's switched on, whatever, and I lost it. Do you hear me now?
It's perfect. I always find it funny when the most technical person is the one struggling with the mic.
Oh man. So yeah, go ahead, Jim.
Sure. So I was just getting a little bit of your origin story, Alex. So Mark was, talking through his there, and you guys sat beside each other at Intel, and from our introduction discussion last week, I got the impression you've been in the space in some way for quite a long time.
Yeah, I started back 2013. I founded the first Canadian Bitcoin payment processor, and ran that for a few months actually before realizing there was no volume to buy consumer goods. But I dabbled since then and looked at the progress of different things, and then I ended up joining Mark, running the data science team over there at Intel, and I guess that's where we sort of clanged back. And then when we got back to the blockchain space, we wanted to build data products. Like that was the goal, and we had a journey leveraging different things in this space to eventually get to build data products. And that's, I guess, how it converged up until today with the graph.
Awesome. So Matt, where do you fit in this picture, and what was your sort of introduction to the crypto world?
Well, first I joined EOS Canada as a contractual, and the first thing they told me is like, okay, Matt, you'll be writing a smart contract, and I was like, okay, what that is? At that point, it's been 3 years, and it was the first time I heard about Ethereum and Bitcoin like almost everybody, but I never understood what blockchain was about, and Alex told me, oh, okay, go read this white paper of EOS, you will understand everything. And frankly, I understood nothing at all. And it was just, and at that point, I started learning. And this is how I joined the blockchain world. It's the story behind it. My first task was to write a smart contract for EOS in C++. So it was quite interesting endeavor from that point.
That's very interesting. So did you come into the space with, would you say, skepticism, or was it just literally you just don't have the knowledge and you want to learn before you make it, make a call? Because I find, sometimes developers or engineers go through this sort of journey of, not really understanding and just believing that these, crypto, the whole space in itself is a scam, but then actually reading into it and finding, that there's real value in this. Were you on that journey, or were you on a different journey?
No, it was really, I joined Mark kind of, we did some contract together before, and he asked me to actually do a contract for him, and I knew nothing about blockchain, apart that it was kind of a chain of block. So no, I was not with any skeptical in mind. It's just I was happy to actually learn about it. It's quite interesting as a technology with the consensus as the distribution of computation. It's quite interesting to learn about it. So no, I was really happy actually to do it, and it was a great learning process from the beginning to today, and it's not finished, right?
Hey, we're only just beginning. This is the first innings, right?
Exactly. It's really funny how Matt says that he started as a contractor. I think a lot of the team has been reeled in this way. We slowly pay them to start learning and discover how interesting the space is and how it's amazing to work alongside Alex. And then the next thing they want is work full time with us. And that's how we've attracted the best engineers, I think.
That's very interesting. So Josh, what was your journey into crypto?
So I started back in 2016. I was a stay-at-home father with my son when my first son was born. And so I had extra time on my hands to start studying stuff, and I've always been an economics guy. So I just stumbled across the Bitcoin white paper at that point and just stumbled down the rabbit hole into Ethereum and further on. And then as soon as my son was old enough to go to daycare, I just started trading full-time for myself, doing arbitrage trading, because the market was really ramping up in 2017. And then shortly after that, got connected with Marc-Antoine. Same thing, he hired me on as a contractor at first. And I remember I told him at first, I only have like 20 to 30 hours a week to give, because I was closing down another woodworking business. And I remember that first week, I'm like, is it okay if I do like 50 or 60 hours this week? Because I got so ensconced with everything these guys were starting to build and working on. So they definitely did a good job at reeling everyone in through the contractor way.
Yeah, clearly that's a very successful solution, the old contract and then pull them in strategy. So Mark, you kind of gave us a little bit of insight to the start of the company with yourself and Alex starting at Intel. What's the history, if you were to give us sort of, a short history on what's led Streaming Fast to where they are today? What would that be from the earliest days, starting at, with you and Alex at Intel, where it's gone since then?
Yeah, so Alex, myself, and Mathieu Boulian, our third co-founder, who's luckily or unfortunately, depending who you are, in parental leave today, he had his first baby on Friday, and we wish him and the whole family the very best. We're super happy for them. So we were, all three of us, exploring some different blockchain opportunities within Diagram. Diagram is a fintech incubator in Canada that is part of the Power Corporation family, one of the largest financial conglomerate in Canada. And they know they're going to get disrupted by technology, and they're trying to innovate from within, right? And so we were brought in, we were working on different blockchain ideas. And something became pretty clear to all of us, was that first, blockchain will disrupt the world, and we wanted to be more at the forefront than lagging. Second, we have a lot of data engineering experience, and it so happens that we see the blockchain as a socially distributed database. And so we were quite convinced that we had some unfair advantage to the space, and we're able to most likely build something special that would be valued. And third of all, very early in the company, we realized that core developers of blockchain protocols were primarily focused on securing their network and accelerating the throughput of the blockchains. But very few teams were focused on solving the access to the data. If it's a database, you need to query the thing. And so we saw that there was a big gap in terms of read scalability and how it would enable developers to easily get access to their first blockchain experience. And that's kind of the initial gap that we set out to contribute to solving.
Very interesting. Alex, you want to add anything to that?
Oh man, that was a good. If you guys have questions to go deeper, I can answer. But you did a good overview here.
Well, I think it plays quite well into, maybe talking a little bit about the grant, how you guys see the grant from your point of view. I think this grant is kind of a first of its kind, right? And the grant itself encompasses a lot of things, including, streaming fast talent, streaming fast IP, resources. We've heard this term a couple of times now by a few different thought leaders in the space. You hear people either calling this a community M&A or a decentralized M&A. And I'm just wondering, does that terminology resonate with you guys? I know you probably have a lot of experience in the sort of VC-backed space, the SaaS space. What does that term mean something to you guys? And what does the grant itself mean to you guys going forward?
So when you think of traditional M&A, you're basically finding a new home to some IP, to some team capabilities or some business value, right? And what was created through this grant, what is phenomenal about the grant, in my opinion, is that we've been able to use some early funding from the investors, from our validator, revenue that we created at the beginning of the company, invest many millions of dollars into creating some IP. And now we're bringing this IP, open sourcing it towards the Graph community. We're going to have this amazing team of engineers and community managers and leaders contribute to the Graph's success. And I understand why this looks like or could be framed as a community M&A. The reality is we're aligned. We're aligned in wanting the success of the Web3 space. We believe the Graph is the best thing out there, and we're going to do our very best, contribute our passion towards the innovation and the evolution of this protocol. And so it's really the showing again the power of network effects that are created by protocols that do things well.
For sure. So would you say that this was sort of one of those situations where a company comes to a fork in the road, and you could have gone down the independent SaaS route, or acquire other companies to build a product, or you could try this new paradigm, I guess, in terms of joining an ecosystem that's not, specifically got a center to it?
Yeah, I think we all felt the fork in the road at some point, where left side was competing with the space and not necessarily being completely aligned with the zeitgeist of the space, and right side was being aligned with the community, contributing to something much bigger than a single corporation. And of course, taking some different risks, but these risks were much more exciting, I think, for the founders and for the full team. Everybody is really excited about the road ahead of us. So, as a founder, knowing that the team is excited about the road ahead is the most exciting and reassuring thing you can dream of.
For sure.
Wink, wink, message to the team. I think some are listening, I heard.
Yeah, we were. I think we were actually outnumbered at one point by Streaming Fast team members for a while there. Okay, so I think it would be I've probably targeted you a little bit too much, Mark, now, and I'd like to move on a little bit into the start of a more technical conversation. I think that, it's pretty reasonable to say that anybody who's been involved in the data space in crypto land was aware that streaming fast made some pretty significant, that's understating it, but some pretty significant improvements to a specific subgraph, pancake swap on Binance Smart Chain. And everybody on this call is keen to hear it from, as we say here in the UK, from the horse's mouth. So let's dig into this a little bit. How did you guys first come across the performance issue with pancake swap? What was the motivation to tackle that?
That's a good question. I mean, we saw there was issues, and we had slowly built a stack of technology that does indexing, and it's always been sort of our core principles to make these things extremely fast, and it supported really high throughput chains, and we just saw these things arrive together. We said this is an issue. We hadn't heard about issues with the graph that we would be able to tackle. It's just sort of converged there. We had an extremely powerful stack, and we said, look, if we add a small layer, we could just go and index much faster with the knowledge we've acquired across the years, and then maybe we could able to solve that. And then we started studying the graph node more, and we relied, actually what we implemented is, the graph node does all the service and the query servicing, and we sort of went and wrote our own indexer and figured out, okay, can we do that? And it happened that we were able to sort of take the subgraph code from PancakeSwap, fit it in our little box there, and do two things. It's like use our streaming tech to push it extremely fast linearly. So that's one thing. And there's a bunch of, we can get into the details if you want, but there's a bunch of things that we tried to avoid to make sure it's fast. And at the same time, one of our founding principles that we got, I guess, from Intel is always be agile. Data agility was always sort of our core premise, because you can't innovate, you can't go fast, you can't, improve fast if your data processes are slow. So, first principle, make everything always parallelizable. And when we're talking about these things, it's about all the levels, right? We have machinery to process, let's say, Ethereum mainnet, the whole network, and extract data from it. We always try to have, our goal is always, I want it before 1 hour. I want that to be within 1 hour. Now, not always, there's some machines to spin, disk to copy, and all that. But the goal is that, extremely fast reprocessing at each level. So even at a blockchain level, and then when we extract data, we can index things in parallel. That's what we did for the pancake subgraph. Now you stop me if I can ramble for a long time, Jim, but is that useful where I'm going?
Yeah,
here?
definitely. I think that's a good intro, but I know for a fact a lot of indexers will want to go deep on this, and I think we absolutely should if you guys are up for it.
So maybe I could just wrap up the parallel thing. So we've infused inside what the subgraph mappings, the notion of parallelism. And so we were able to take the subgraph and go on 4 different passes, but all these passes can be done in parallel. So we were able to actually process the PancakeSwap subgraph in 5 hours. The whole thing, the whole history, that's for the V1, a thing that was crawling for 2 months with no end in sight, right? So I think that's very exciting. There's some of these things we're going to propose to the community, just a way of thinking to start with, and we'll see how far that goes, right? We have an implementation. It's not within the graph node, and so we will want to see with the community where we go with that. What's the appeal and how fast we can bring that to everyone, because it's not, it was not, when we did it, it was not thought as, okay, that would become the next version of the graph node. We did it as an exercise somehow.
Yeah. So just, on the specifics of the performance improvements, I did have a quick discussion with Josh about this, but I guess the published number was something like 57x, right? But I mean, was it, there was also some report somewhere, depending on where you look, of, much higher, like magnitude higher. So,
the thing is that, because, when we started, the graph was sinking, the subgraph there was sinking for a month and a half. And then we were able to at a certain block height, to go at a certain speed. And we looked the two together and say, okay, we can reach it 1 month. So the first ratio there was 57x. But then the other graph would actually never have ended, because it was like going slower and slower. More and more pairs just meant it was going slower and slower. So, we could have put the number out infinity, because you were against something that was never going to finish. And whatever speed you have there and you think you're going to finish, right? So the number on the website was changing because it was using some slightly, awkward comparison. Another thing not moving at all, plus us moving 5 blocks, the ratio was very high. So all in all, the number I would keep in mind there, the linear process was much faster. So 57x, we were able to keep it consistently 12x from real time on a Binance Smart Chain, even at the most deep, because the Binance Smart Chain during that period has also increased in throughput a lot, many times fold. So that we were able to sustain the real-time pace at many x the real-time pace. So that means, it's actually a workable process. But if we compare with the parallel processing, now it becomes an absurd number, right? Like 800 times faster, because we're chunking it, and then you just put more computers at it, and you get, faster indexing. And that has been proven to be very useful. So because you can actually iterate, try what's going to be the value today, but if it takes 2 months, you can't really iterate on your process, on your index, right? On your mappings and whatever. So the fact that we were able to re-index in 6 hours and get the final number, well, we did that many, many times, and iterated and improved the numbers with the PancakeSwap folks, which they were really happy. So I think that's really exciting. Whatever.
Yeah, that's amazing. I'm wondering, and maybe other people are, about like a little bit more technical details. Like, were you guys modifying an ETH client to change the way that the graph node queried it? Were you guys, or could you guys talk a little bit more about that?
Yeah, of course. So, one of the core technology that we've built across the years is streaming fast. It's really the core streaming technology. And if you allow me to go a little more technical there, is we have instrumented blockchain nodes to detach the data from the nodes, so as fast as possible. So we do one execution of the blockchain, like executing transaction, and we spew out, you can imagine the node outputting on standard output, right? Spewing out all the data there is, everything that's happening on the blockchain out as soon as possible, so that you never actually need to go and query the node back. And we put all that data in files separate from the node. So that can be easily read in parallel, right? And you never need to go back and re-execute, do a linear sync of a node. It also means that if we have snapshots of the state for the blockchain node itself, we can actually process the blockchain itself in parallel, producing the files that in the end, when they're all laid out contiguously, well, you have the whole history. And then from those files, so there's sort of a process we call let's call it the Firehose, for lack of a better term. You can imagine what that means. It just spews out everything from a live node. And then adjunct with the history in files, plus a stream from the Firehose of a node, we're able to offer that thing we call the Firehose. It's a service, very simple service, that gives you raw data from the node, including all, our design principle was we want to output everything that is going to be useful so that we never need to re-execute the node. So all of the data, everything that happens, all nonce changes, all balance changes, all state changes, and we have that very deeply. Let's say an Ethereum node, we have the full call stack, all the calls that are done, calling another subcontract and then another contract, and all the return values, all the state changes that are done, and within the scope of each of those subcalls, you have a tree, right? So you think of the parity traces. All of that information is spewed out. And then we use that as the source for linear indexing. But the thing is relying on files, so it's extremely fast, right? You just download, and the cost is very low. So that's how we did the linear processing. The only input to the subgraph was an extremely high speed, stream of raw data. No ETH call. So that's what compromise we wanted to say. If we want to go high throughput, we need to limit all the ETH calls. Anything going back to the chain, and there's risks of inconsistency, there's error handling and all these things, right? Which you don't have when you just process data. There's not even a error checking when you're processing data. It either crashes the program or continues with high guarantee. So I guess that's the first thing we did. And to answer your question more directly, for that we do have special instrumentation for nodes, which in other protocols have been merged directly in the nodes, right? The node is instrumented to spew out the data in this fashion, and we think it's we started work also on Solana to implement that same behavior, right? So that the nodes themselves spew out the data, and then we work with the data. And so today for Ethereum, we do have instrumentation for Geth, and also for Parity or Open Ethereum, which outputs the same sort of data. We have test suites to validate that. So no matter what the client is, right, the data is king there for us indexers and for us who want to value the data. Does that help? Does that,
Yeah, very cool. Thanks for the explanation. So do you have an API that you have built abstracted on top of the trace data?
So the raw, but maybe I could point you guys to one of the a repository. We have a sample client there. If you go to Streaming Fast on GitHub/streamingfast-client, you'll see there a sample output. You can imagine a block as so the whole of our stack was gRPC and protobuf. Our goal was to have the most robust definition of the data for each protocol. So we have that for 2 or 3 protocols right now. And it's accessed through gRPC, which allows, a lot of languages to just quickly scaffold and have typed data received, and it's more compact, well known. So that's sort of a choice we made there. And that API streams units of blocks, and in there you have traces, execution, and in there you have calls, and in there you have state changes, balance changes, and all the things, all the data that you would ever need, I guess. That's the goal. Maybe there's some missing bits today. My goal was if we output the data from the node, we should be able to reconstruct, in theory, a node from scratch just with the data, right? I guess that'd be a goal.
Yeah, absolutely. Very cool.
So you mentioned there, Alex, and just forgive me with this is me coming at it as not as a developer, but one of the things that indexers would be interested to know is, and maybe it's too early to ask this, but maybe and indexers are interested to know what we might expect in terms of requirements around our infrastructure today, which is it's relatively simple. We have a graph node, we have a Postgres database, we have an agent to manage the things on chain. What might we expect in terms of additional requirements for indexing? Are we talking about additional compute resources? You mentioned that the stream or the Firehose is essentially outputting a bunch of files. So are we talking about flat files architecture here, or
Yeah, good.
Just interested in what it might look like to an index.
Right. So just to be clear, we're arriving here. We have that technology, and we don't want to impose that. I think it's going to be like we're working to make it optional so that someone can use the nodes like it's set up right now, and maybe eventually, as we discuss, we can have features that either require it or leverage it in an awesome way. But I'm thinking today, if we are using, because we're working to wire in that sort of stream within the graph node today, and that could help, for example, speed up the call handlers, which would normally turn around and then query a parity node for its traces. But now all the data just is pushed to you, so there's nothing to go call. So all of a sudden that becomes maybe a pattern that works well. Now to the question, what does that mean for the indexers? Okay, there's 2 aspects of it. First, I think if it was solely an approach of streaming, I think it's very resource efficient, because you need a node that just needs to be synced to head and provide the latest data, and the rest are, like you said, flat files that are ZSTD zipped and are just like a bunch of proto buffs of blocks. that contains everything well structured. So that's extremely simple, for example, to share and bootstrap someone. You just copy those files and all of a sudden you have the history. You don't need to process linearly your get node because you have the data, and that's what indexing is about. And then you can run just the live node to continue providing and building what you don't have after you've synced with someone or shared those files. So, but at the same time, if you want to run the current infrastructure and you want to dabble with what we might be contributing there as respectfully as we can, then you'll want to have a node that is instrumented creating those files. And there's 2 or 3 processes that go around that to make it highly available, right? So that you have 2 nodes and both of them are sort of, the first one to see a block pushes it to what we call a small relayer, and that one sort of converges, deduplicates. So you have sort of a high availability setup for these things. Does that make sense? And then the graph node, just indexing based on that first service there, which could eventually, so that's one of the thinking, like become, I don't know, I'm just throwing that out, might be done, might not be done, become a network subgraph. I think there's been chatter about that eventually. In the past, perhaps, we're still gleaning around, the nuggets of knowledge and the history here, but, it could become a thing where that, Firehose becomes a service on the graph, and that it's valuable in itself. So you can feed your own subgraph on, someone else that runs just that layer of network subgraph raw data, and then you do like mappings and other subgraph indexing. And so we can see a lot of things cropping out of that.
Yeah, I've got that on the agenda for sure.
Oh, sorry.
Brandon, did you want to chime in there? So you.
Yeah, I was just going to echo that. Definitely, pretty much from day one, we've talked about the possibility of doing like what we call subgraph pipelining. So right now you have subgraphs ingesting from the underlying blockchain and then consumed directly by an application, but there's no reason that those things couldn't be composable. And so, yeah, what Alex is saying, makes a ton of sense, that you could have subgraphs that like represent the underlying, network firehose like he's talking about. There could also be really interesting like post-processing cases, right, for various like analytics or like more traditional like OLAP style views on data.
Right. Just some feedback for you, immediate feedback, just with talking, from an indexer's point of view. What you'll find is that majority of indexers are decentralization maximalists, right? So most indexers that have the time to do so run all their nodes themselves. So client nodes. So, I would expect that you would see less indexers interested in a service where they copy a set of files from another source. And you'd see huge amounts of interest from indexers who can generate that stream themselves from Genesis on whatever chain they're working on.
Of course.
And providing that as yet another, maximally decentralized service. Me personally, that's the way I would want to do it from day one. I wouldn't be interested in making a copy.
Of course. It's just an option. It's just like someone who wants to go ship something quick and say, like, give me a copy of the level DB of underlying get to start faster. But of course, if they want to have verified data on their own, they'll want to run from Genesis and linearly and all that. So these are, same sort of option as you have today, and you obviously can run it. In that case, you'll run it linearly, and we try to make the burden on the output absolutely as fast as possible, right? We want the instrumentation that we have added on get to be as minimal on performance as we can.
Absolutely. And I wanted to clarify. Sorry, Brandon, go ahead.
Yeah, I was just going to mention that's a decision that we're going to have to see indexers making a lot as we start seeing a lot more composition of subgraphs, right? You can imagine once subgraphs form, this kind of global graph where most subgraphs are interconnected to one another by referencing entities in other subgraphs or pipelining other subgraphs. Aside from just this use case, you're going to see indexers have to make a decision how much data to kind of index and keep locally versus, maybe relying on external quote unquote services really would be other, indexers potentially for some of these cases. But it's a really interesting observation.
Right.
So I just wanted to rewind a very small amount there, Alex. You mentioned when Ford was asking about a bit more about the specifics, that you guys get involved with and have successfully worked with other clients, as in blockchain clients, to integrate streaming fast requirements, needs, technology into those clients. So I'm kind of interested to know the context there for say Ethereum, where at the moment as indexers we only really have the option of the RPC interface, right? There's the WebSockets interface as well. So would this, if you were to be able to achieve some level of compatibility with Geth, for example, would this be like another interface that we can make use of, assuming that the graph node was able to support it?
So another interface. So the Firehose itself is a service, sort of detached, and by the way, is blockchain agnostic, right? The streaming protocol that we created gets fed by an instrumented Geth, instrumented Open Ethereum, an instrumented Node EOS, or an instrumented Solana node, or whatever other protocol, right, where there's some sort of linearity, contiguity of blocks. Then the Firehose can support it. Now, that's a new interface. It's a level like just slightly above the node, and yeah, I mean, that's one of our proposition. And there's some other really interesting goodies that come out with that. Is it's all it has to do with eventually consistent blockchains. Anything that has to do with reorgs and forks, I think we're at the 8th iteration to make sure that this stream of data that we're getting out actually allows you to navigate reorganization and all these things. It keeps a history of the fork, so you can always come back, a few days later and continue that stream, which is something that the node itself cannot really do, because a node needs to continue on and flush the other forks and continue on linearly. And when you query a certain, let's say an Ethereum node for a block that has been, oosted out, he's not going to keep the state for that. But having a small data layer just above, collecting that data, collecting the fork information, allows the downstream services to be much more robust. So, I'm not sure I get the question about within the client. It's not an interface we think makes sense inside Geth or inside Open Ethereum. I think it has its place as a thin layer above that is sort of blanketing different protocols and providing that greater certainty of reorganization. So yeah, does that make sense?
So you're further down the application stack, right? So you're below what would make sense to be like an API on the software itself, is what I'm gathering. Okay,
that's what I think. Yeah,
that helps me a lot with the context. Thank you.
Hey, Streaming Fast, thanks for joining us, and congrats on the grant. Really fantastic to have you in the ecosystem. I have a few questions. The first relates to what we've been discussing about, a kind of instrumented node. To put more specifics to it, to me it sounds like, in the case of Ethereum, like an instrumented EVM instance that then actually, is capable of spitting all of this data out into flat files. And obviously, if the alternative in the context of OE or Geth is JSON RPC, the alternative is incredibly expensive. So that makes a lot of sense. With that context, it feels like the latest developments on Aragon are really approximating the same architecture. Maybe not exactly. It sounds like, you mentioned that your flat files store the data in binary protobuf format, whereas, Aragon's obviously using MDBX. But fundamentally, there's that separation of concerns between, the blockchain node itself, that obviously fetches blocks off the P2P network and runs them and, does all of that kind of thing. And then, the RPC daemon, which actually responds to JSON RPC requests and does all of the serialization and deserialization. But the Aragon node itself does have a gRPC interface to access the underlying data in MDBX, which obviously includes all of the detail, all of the traces, everything like that. So, I certainly appreciate the approach that you took was targeting kind of moving fast, as fast as possible and so on. But as you kind of look to, mature that approach and bring it into the graph ecosystem, have you looked at what Aragon is doing and do you think that most of this improvement comes from the separation of or essentially cutting the JSON serialization and deserialization out of the stack, and then obviously the network layer as well? How much of the benefits do you think would carry into Aragon's approach? And just keen to see how you think about that.
Well, I have to admit that I have not wrapped my head around all of the things around Aragon. So you're talking about a lot of these things I just don't know, right? I think there is, like from a data science perspective, having things in flat file is extremely valuable. Like just for parallelism, you have a process loads exactly what it needs and then processes it in parallel. I think MDBX is a sort of a level DB thing, right? It's a key value store. That is more difficult to you copy. I don't know. I'm not sure. The truth is I don't know. And I'll be very excited to see, because I've been a little confused. There's a lot of things in Aragon. There's a DAO, but you're saying there's nodes and there's data structures. So I'm actually very curious to learn more about it. Maybe you can send me a few links, or I can do later on, and we can dig into that. Because if there's synergies or better ways to do things, by all means, we'll want to be aware.
Yeah, happy to do that. The name's slightly confusing because there's Aragon, Aragon, which is the the DAO framework, and
Okay.
I'm talking about Aragon. That's Erigon, which is essentially the rebranded TurboGeth.
Right.
MDBX is an evolution of LMDB, so it's a bit different to LevelDB, but yeah, I take your point around, the ability to parallelize workloads over different data structures. But yeah, definitely something worth looking at, I'd guess. If I may move on to the next question, does anyone else have anything on that?
Go ahead, Chris.
Cool, thanks. The next one I guess is around how you actually parallelize the workloads. It sounds like there's some level of modification required to the subgraph definitions themselves. So the subgraph developer is responsible for indicating to the indexing process which components are parallelizable. That's a hard word. Is that right?
So we will be putting out a proposal, because it's actually a little mind-boggling to think about that. There's many passes and there's certain operations you can do to sort of reduce, But so what we'll do about that, we will send out sort of an RFC, or just a proposal, not a proposal, but a way to explain as clearly as possible what it entails to have sort of mappings. I can give you a short summary here, but that's what we're going to do after anyway. What it entails to enable parallelism. So first of all, things need to be cut in sections, right? There are, let's call these segments. That's what we call them in our code. Segments, that's a range of blocks, let's say 10,000 blocks, and another 10,000 blocks, and then you'll have different segments up to the sum of the blocks. So let's say you have 100 segments for the whole chain. And then each of those segments will pass many times. You will have the first pass. Let's say the pancake swap thing. First thing we need to get is the pairs. We need to learn about all the pairs, because you cannot do some computation that requires the presence of all the pairs before you get all the pairs that are present at a given point in time. So first pass is just get all the pairs in parallel, and then we output just the pairs data. And then the second pass can go and read the pairs that were discovered previous to their state, previous to their segment. And then they can do a little bit more work because they're aware of the pairs. And now they can do, just the count of transactions. That can be done on step 2. But then certain things required to have the count of transaction plus the pairs plus whatever other thing needs to be done on step 3. But all these things can be done in parallel. And it's fascinating because that operation, step one, like we have the pancake swap thing on 4 steps. Step 1 will take in parallel 5 minutes. It'll process the whole history of pancake swap, and we'll spew out the pairs. And then the second step will do just slightly more work, and that one takes 7 minutes. And then like step 3, I recall how long, maybe the guys can jump in 12 minutes and then 25 minutes or 30 minutes, something like that for the 4th step. And that all prepares files, data that is laid out on disk, and then there's a step to sort of cut it on another side, slice it. You have it segment in terms of block time windows, let's say, and then we have another time where we slice it in a different way, in entities. And we're going to read for all the segments a given entity and create CSV files for injection at the highest speed there is in Postgres, and inject that through a copy from with just streaming the CSV. And then we did some optimization there. That's our process to have it shrink in 6 hours, remove indexes and create indexes after that, like bulk loading was done. And then I guess that's and we did a lot of optimization, chose indexes there. So that's how we managed to do the parallel. But so there's some knowledge that needs to be taken into account by the person doing the mapping, as we needed to annotate in code. Don't do that unless it's after step 2. Don't do that. Don't go as far here until you're at step 3, because the code below that little marker relies on data that has not yet been produced or properly computed. I don't know if that makes sense. It's a little funky. We'll try to make it in writing as clear as possible. It's just to, sort of start a conversation around that. Does that make sense?
Yeah, it does. Thanks. It sounds like the subgraph developer needs to be aware of the kind of or conscious of the programming model that they use, such that it is parallelizable.
Exactly.
Which makes total sense.
I told you there'd be some good questions, Alex.
Good.
Just to dovetail on that, it's a really great question. And I think I can't remember who said this earlier, but up until now, dApp developers have largely been focused on write throughput. That's kind of been like the metric people care about, and it shows in the way that people write their apps. And to the point of the question, you're going to see a lot more of, I think, people thinking about read scalability. As we kind of hit these like next levels of scale, and as like L2s kind of unblock, sort of the next level of write scalability, we're going to start seeing a lot more focus on, the developer having to actually take that into account as part of their workflow. And one thing we've talked about, I think internally, and I'm sure we'll be talking about this, with streaming fast as well, is like, even the word mapping for subgraphs is a little bit of a misnomer, right? They're actually like closer to reducers, right? So you're mapping over all these events from the underlying blockchain, but then you're also processing, the database state. So you're actually reducing over the state that you've created, in that mapping. And, finding a really good developer experience and like a really good subgraph API for helping developers break down those computations. So like maybe you have multiple map steps or multiple, and then followed by a reduced step, so that these things could actually be run concurrently. That's going to be, a big part of the work, I think, moving forward, in addition to the actual, sort of technical plumbing to enable that.
Yeah, that's very right. I think you're right on the naming there. And in our work, we tried to, to minimize the impact on what it would look like. But I mean, I appreciate the fact that you're even open in the future to consider different ways, because that will open a lot of different possibilities. Imagine if you had 4 steps in small mapping files, and then you would really be doing a map reduce, and that can scale up. Maybe that becomes a different service, or something like that. I think there's a lot of innovation that can still come through, and this is just our first take on it. And if it can help stir a conversation, that'll be cool.
Awesome. Great conversation, guys. I know that there's people with more questions, but I'm cognizant of the fact we have 4 minutes left. I want to make sure we tie this up nicely. I did want to get into the concept of the Firehose as a graph protocol service in more detail, but I don't think we have the time to do that, unfortunately, today. Maybe another session. There are two questions I want to make sure that I do ask before we try and wrap things up. So the first, just sort of rounding back to streaming fast sort of integration with the ecosystem, the community. A question to any of the team: what does day one look like for you guys in terms of code contribution? What can indexers expect in the short term? I know you've mentioned potentially some RFCs you want to post on the forums.
Right now, what we are working on is actually having a proof of concept of GraphNode powered by the Streaming Fast API. So we are connecting our BSC Streaming Fast gRPC connection, and we are connecting it inside the GraphNode to actually power. So instead of relying on the RPC node to actually fill the blocks, events, and the calls, it would be fed from the Streaming Fast API. So this is the first thing that we are doing, and we have some other smaller tasks about indexing performance around doing some asynchronous work, like on the proof of indexing or pipelining some blocks in advance for the RPC provider. We are all hands on Rust right now. We are Golang shop. So we are trying to map our knowledge of our concurrency patterns to Rust, and this is what we are doing currently.
Excellent. So in doing that, another question for anybody in the team: is there anything you need from the indexer community? Is there anything that we can help you with testing? And also, what's the best way for people to reach out to the team?
So you can reach out to us on Twitter, and we're all present on the Graph Discord channel there. We'll be crawling the forums also if there's any proposition. Our goal is to really get engaged with all the different governance entity, and our goal is definitely to gather as much feedback as possible on the things we've done, but also on the things that are currently happening that we don't know. Like we're working with Edge and Node and the Graph Foundation to that have a clear vision of the ecosystem. We want to gather that sort of first-hand feedback to get really involved. So if there's any things that you see, like we said a few things today, if it resounds with you, or then reach out. We'd be really happy to get that first feedback, to understand where the community is at and where we can have the most impact for the Graph network, right?
We're also working a bit on some RFCs, just so like writing down current ideas behind the parallel steps and the way that we've mapped different steps that can be run, that can be run in parallel. And it's kind of a work in progress RFC. You know, there's definitely no final details about the implementation, but it can be a good groundwork for indexers to see, oh wait, that resonates with me, or oh wait, definitely we will need some kind of POI on the on the network subgraph, or POI on block data files, before we can use this as for streamlining different subgraphs and all this. So all these questions that a lot of people have somewhere in their head, we're trying to have enough, maybe open a PR just for comments and get some feedback on what issues do you foresee just with the idea of having files to do some parallel work and having steps defined by the subgraph maintainer, and all of this. So I think that's a first step for that.
And Jim, if I can, I'd like to put out one little thing there, is that we're also, in terms of code contribution and going to open source, some of the things in Ethereum land that were not yet open source. A lot of the stack is already open source, and of course the code that we have written for the swap stuff. Although I want to say, call to you. What do you think? What do you guys think? My goal is not to create a fork. We don't want to create a fork. We want to unify the community. There is some code we might put outside as an open source, and maybe we stir up a conversation sooner than later as to what we do with that. There is some innovation. We don't want to split the community and sort of go too hastily in that. But so is there value to be brought by the code that we have already done? Is that, are we more patient and want to reel that inside the Rust code base? These are discussions I'll be happy to have sooner than later. It will help us steer, our decision making, and see how the community is hungry or thirsty for, I don't know, innovation or whatever.
Absolutely. Yeah. I mean, I think there's endless conversation here to be had yet. But we're past our scheduled hour, so I want to respect everybody's time and just wrap things up today. Just so people are aware, if you're looking for more information, you're hungry for more information right now, GRT IQ is releasing an interview with Mark tomorrow at 1 p.m. EST, so keep an eye out for that. Again, I want to extend the warmest welcome to our friends at Streaming Fast. Thanks to everybody, all of my guests today, for being so generous with their thoughts and time. And we'll see you again next week on Office Hours.
Thanks, Jim.
Thanks a lot, Jim. That was really good, and thanks to everyone. We're really happy being part of this large community now.
Thanks, guys.
Bye, everyone.
Okay.